Let's graph some parametric equations in Excel. First, we'll define what a parametric equation is compared to a non-parametric equation. So we're used to saying, here's a formula, let's graph it with y on the y-axis and x on the x-axis. But for parametric equations, we're saying x is determined by some function and y is determined by some other function, both of something called a parameter. This is why we call it parametric. And that t parameter is often time, but it doesn't always have to be. Let's go try graphing this set of parametric equations in Excel. So let's have a t column and x and y. Let's start t at 0, and I'll just say what's cosine t on the current row. So just cosine of that. And what's sine of t on the current row? That. And then we need to take like the next t value and the next t value. Ideally, we'd use infinitely small steps. Here, let's just use like steps of 0.1, for example. And then I can fill this down. Let's fill this down and get something up to like 6 or so. And then we'll fill this down. And now let's graph it. What's going to happen if I graph all 3 columns? I get sine and cosine, but this isn't using the horizontal axis as my x values. Here my horizontal axis is my time values, just like we did in this graph, which is kind of interesting sometimes, but that's not the point we're trying to make here. So we don't want this graph. So we'll say don't want this graph. It has time on the horizontal axis. What we do want is just x and y, x on the x-axis, y on the y-axis. Let's do that. And we'll again do dots with connecting straight lines. Did you expect to see a circle there? Well, with sines and cosines going on, maybe it's not a surprise. Is this actually a circle? Doesn't look like it, but if we look at how big the y-axis here is versus the x-axis, its aspect ratio isn't exactly 1:1 x to y. So if I stretch it out, I would kind of have to measure it carefully on my screen to make sure I was getting near a 1:1 aspect ratio. I think we're getting closer there. So that's how to graph parametric equations in Excel. You have to set out some time values and then compute the x and y values at each of those time values, and then only plot the x and y columns, not all 3 columns. We can have a little bit more fun with this. Let's look at the progress of time. Let's get rid of all but the first 2 time points. So it says we're starting here at 1, 0, and then we go to 0.995, 0.9, so that's here. And then if I take another step and another step, it's drawing a straight line back because it's treating all these as 1, 0. So ignore that straight line coming back. So you can see as I take more and more steps, I'm moving around the arc of the circle. It looks like I just got to kind of the 90-degree mark, and my t value just got to 1.5, 1.6, which is pi over 2. So hopefully that makes some sense in terms of radians. And so I can keep going around the circle like that. And if, oh, let's not do that. Here I just got past pi, so I've done a full circle. And then we'll do a little more and a little more. So we're up to 5 radians, getting close to 2 pi. Let's move this down here so we can see what happens. And then do a little more, getting close to a full circle. And then 6.28 radians would be exactly 6.28 blah blah blah, 2 pi radians would be a full circle. We're pretty close. And then if we keep going, we're going to trace out the circle again. Can you see we're getting kind of doubled up dots there? Not quite exactly doubled up, but close. So in parametric curves, you can trace out the same thing repeated times if you just let t keep going.